might have seen kind of a lack of videos lately, and that's not because I don't have a lot of subject matter. In fact, Quindor sent me ages ago, I think around 5 months ago, he sent me a whole bunch of 24-volt power supplies to tear down and to see how they hold up. These are 3 Chinese power supplies, so eBay, AliExpress, that kind of stuff. Very cheap power supplies, significantly cheaper than the other 3 he sent, which are Meanwells. Meanwell is a fairly respected open frame power supply manufacturer. My opinion of them is that they're not great. It's not Delta quality, it's not server grade quality, but it is really decent stuff. It won't fail on you. He is building a giant LED array in his new house, and he wants to know, can I get away with buying Chinese cheap power supplies, or should I really go for these Meanwells? Now, the reason these have been laying here for so long is I was actually expecting 3 other 24-volt power supplies, and I just wanted to do a giant, big blowout sale, do all of them together, make a big matrix, see their efficiency graphs, see their internals, see everything. Unfortunately, those other power supplies are just not coming, so I'm going to do these today. Unfortunately, also, my power testing setup is down at the moment because I'm working on my AC power meter stuff. So what we're going to do first is answer this question, essentially. What are the big differences between the Chinese power supplies and the Meanwell power supplies? The first thing you'll notice when you shop at, for instance, eBay, is that most power supplies, if you're looking for a 24-volt open frame power supply without a fan, they really don't differ that much. And Quindor specifically sought to look at differently shaped power supplies, essentially. Stuff you could see on the outside that might be good. For instance, this power supply is also, he doesn't mind if I break them. So that's why there are 4 science stickers on there. This one is in a very thin aluminum housing. There just isn't that much power dissipation going on. There are the switches are here on the back. These screws, they don't just hold down the board, they actually hold down MOSFETs and a diode on the other side. But it is relatively thin. There are no corrugations. There's no real good way to dissipate the heat. And if you look, it's a 240 watt power supply. Say this is 90% efficient, it'll have to dissipate 24 watts. And 24 watts is not a small amount. And it's certainly not something you can dissipate with a flat plate. Because the amount of heat that's actually conducted to the side is minimal, because there's these slots here. So most of it will have to be dissipated by this plate. And even if you put this vertical on the wall with some space between it, so air can move upwards through it, it really isn't enough. So of course Quindor knew that, and he sought out to look at power supplies that, this one can blow up extra much. This one definitely uses, it's certainly different, it uses a much thicker chassis. This one, of course, has the eternal problem. Something that the Meanwells also do is they have just the inputs and the outputs next to each other on one side, so it's extra easy to make sure your mains is on the secondary side. I really don't like that. I don't like screw terminals to begin with, and I really don't like the whole idea of having all these connections on one side. Now I have to say, again, this is a 240 watt power supply, and this one, aside from having like a chunkier cooling solution, which probably would actually work, so it's got way more output terminals for the power. It's got 3 ground and 3 positive voltage output terminals. First of all, that is convenience, but second of all, there's quite a lot of current. There are still 10 amps going through here, and 10 amps is not something you can carry on normal 18 gauge wire. you need at least 2 wires, and even with 2 wires, there's kind of a lot of losses in there. So this is good. Somebody thought about this. Somebody did the right thing. I'm not quite sure, but as far as I know, the European directive, EMC directive, says anything over 75 VA, so 75 volt amperes. If you don't know what that is, I will make a video later about the power factor. Essentially, everything over about 60 watts-ish, 50, 60 watts, has to have active power factor correction to make sure that the power factor is at least, I think it's 0.8 up to 150 watts, and then above that you need to be 0.9 or better. These are 240 watts, and they draw 400 or more VA, so these are not compliant. You cannot use a lot of these on one fused outlet. For instance, you have 16 amp breakers. Normally, on a 230 volt power system, you can use 230 times 16. It's like 3.7 kilowatts of power. With these, you can't actually use 3,700 watts of power. You can use 3,700 VA. So if your power factor is lower, for instance, if your power factor is 0.5, then the amount of VA that this pulls for the amount of watts that come out is twice as high. So, and these run at about 0.56, so around 0.5 power factor. So that means you can only run 1.8 kilowatts off of one breaker. Now the last one Quindor has is this, and this is actually something where they seem to have thought a lot more about the cooling design. So first of all, if you mount this vertically, it's very long, and it's got these fins on there, and the fins actually have power devices on them. So these fins definitely provide the most cooling of everything here. This is also a 300 watt power supply, so it's a little bit beefier yet than the other ones. And it's also the heaviest, unfortunately, as with most of these power supplies. Fairly wimpy, like these. Let me just show you. These screws are even smaller than the screws on the other Chinese power supplies. So the conclusion here is that even though most power supplies look alike on eBay, there are some differences, and some differences for the better. And like from the outside case, you can already see that some have better cooling, so I'm probably going to survive for longer than others. So we're going to focus on the difference between the Chinese power supplies, and I guess this one's Chinese as well. You know what I mean. And the like higher quality name brand one. I should say no name and name brand probably. So here we have the Junke. that is the actual name. Power supply, and a Meanwell LRS-150-24, which is a 150 watt 24 volt power supply. This one purports to be 240 watts. This one, it does have ventilation slots, but not a lot, honestly. And the quality of the plate work, as I say, this is one of the easiest ways to see how the quality is of a power supply. There are very rough burrs on here. Some people say, "Oh, why the fuck do you care? What's so important about this kind of quality?" Well, you can see they didn't fully punch out this hole, and there are tiny little metal burrs. And those burrs, if they would be slightly looser, they can come off over time and cause a short somewhere. And this doesn't just go for this shape of burr. Mostly, these kinds of imperfections, they're long, thin strands of stuff, essentially just wires, and they can short out very dangerously on the board. And compound that with the fact that there's just not a lot of protection on these PCBs, and you can quickly get into trouble, especially if you employ 10 or 20 of these, and that's what Quindor is doing. Now compare that to the Meanwell, which I just find interesting that they put so much thought into the case. They just have one screw here, and then it slides off. There's like an actual mechanism to it. Doesn't come off quite as easily as I thought. But yeah, it's much more ventilation. They have an entire honeycomb type deal on the top cover. The top cover is actually steel. Only the bottom one is aluminum. Now we have both of these power supplies open. We can look at the differences on the inside, and at first doesn't really look that different. You've got the input, you've got some filtering on both ends, you've got a bridge rectifier, you've got your primary filter caps, then you've got the primary switches. This junky one seems to be two power supplies in parallel. So there are two switches, two transformers, two diodes. Very interesting. This one just has one switch, one transformer, and then one diode on the secondary side. But if you look at the subtle differences, they're quite big. So for instance, here on the junkie, there's a small glass fuse here. If something goes wrong in a power supply, the purpose of a fuse is to prevent fire, or to prevent a fire hazard in general. So it breaks the circuit if excess current is drawn. So the most likely cause of that is either an overvoltage situation where the MOV shorts and causes excess current, and that separates the power supply from the mains, or one of the primary MOSFETs fails, shorts, and excess current is drawn and the fuse blows again. This excess current can be in the order of 100 or 200 amps momentarily. And these fuses, they don't just fail, they kind of fail explosively in the worst kind of situation. Not necessarily always, but they can fail explosively. That causes damage, and that causes collateral damage. You don't want that to happen. You don't want the flaming embers of a fuse running amok through the rest of your stuff. These are open frame power supplies. They are not contained. So if this is vertical on a wall, the fuse breaks and spills material all the way down onto, for instance, other electrical equipment. That could be a problem. So the way to prevent that is, well, if you want to be really cheap, you can still use these glass 520 fuses. Just put heat shrink around it. Usually they have special extra thick heat sink, or you put 2 layers of heat shrink around that. The other option is to use ceramic filled fuses, like I did with the Meanwell. Then we have a look at filtering, and in this case the filtering is also not quite good on the junkie, and adequate, not perfect, on the Meanwell. So the minimum amount of things you need for like a proper filtering stage is you need your input AC cap, a differential mode filter, and differential mode means you have a differential choke like this. You can see 2 windings around it, one for one of the AC lines, one for the other AC line. This forms a differential filter to ground using these small capacitors here, these blue capacitors. And then it also forms a common mode filter using this capacitor here. Now on the junkie, all we see is an input filter. The AC lines go around here, start here. There's one capacitor, then there's a common mode choke, and that's it. There are none of these blue what are called Y capacitors, where you do differential mode filtering to ground, and there is no common mode filter capacitor. So this is a very inadequate filtering stage. Kind of interesting to see is that they do actually have overvoltage protection. This is marked RT1, variable resistor, so this is almost certainly an MOV. And here, the same. Oh, actually, excuse me. This is RTH1, and this is RTH2. So these are two thermal resistors, which means NTCs, which is inrush current limiting. This doesn't actually have inrush current limit. This is just an overvoltage protection thing, and I think these are marked ZNR5. So these two are probably the actual overvoltage protection diode. So that's all right. It's nice to have transient protection. We have the primary capacitors, and first of all, let me just say, for a brand name power supply, using Lelon capacitors, I mean, I know they are the primary capacitors, and primary capacitors don't matter. Still though, Lelon, that's kind of a C brand. Unfortunately, on this one, the brand is FEC. Yeah, FEC brand. That's as no name as you can get. These are probably not even close to their rating. They're also significantly smaller than these, even though they are higher rated. They are 100 microfarad rated. These are 82 microfarad rated. So there's meh. Of course, primary caps don't really matter. We're really interested in the secondary caps. Everything is basically par for the course. The switching stage, it's so simple. There's almost nothing you can do wrong. There's a primary switch, there's the transformer. Nice thing about this is it uses real 3M tape. That's usually a good, it's not necessarily mark of quality, I mean 3M, whatever. The thing is, it's properly encapsulated, it's properly shielded actually, so there is ferrite all around, so there is no magnetic emissions coming out. These transformers, they just look a lot worse up close. They are very messy. They didn't really take much care in winding them. Output diode and then the output capacitors. Kind of interesting to see there's no overcurrent protection on this. I would have expected that on a name brand, but who knows? It's not that important. And these output capacitors are Rubicons. The output capacitors do matter. And there's actually, it's not just output capacitors, there's an CLC filter, so it's got a reasonable ripple rejection on the secondary. That's good. On the no-name side, we see output capacitors, which are, again, FEC branded, FEC. There is, though, a proper CLC filter that will also have reasonable ripple rejection if they actually took care to tune this well. Because what I do expect on this power supply, because they have two power supplies essentially in parallel, if the frequency of these power supplies, if they are actually completely separate, then the frequencies of the power supplies can differ just a tiny bit, and you can actually get a beat on the output. That will be a problem. Alright, so that's it for this video. I just wanted to show you what's really different on the inside, what you're paying for, and why you're paying for it. Because there are differences, and I really wouldn't recommend this power supply for a couple of reasons. I mean, aside from the quality of the components, the quality of the filtering, there's also just, why would they put two transformers in parallel? This doesn't make any sense. There are transformers that are just the same size as this that can do 240 watts, no problem. They just copy pasted two 120 watt power supplies next to each other and called it 240. That's not really how you make power supplies. Same goes for just minor construction details like this bridge rectifier right next to the primary capacitors. Primary capacitors don't matter, but they kind of do matter if you let them get really hot. And this might get quite hot because it's a small bridge rectifier, so small area to dissipate that heat. Likewise, these capacitors are just flapping in the breeze. They're not held down by anything. They were never held down by anything as far as I can see. Maybe they were supposed to be tie wraps. Maybe that's like there is a cutout in the board. Maybe it's supposed to have tie wraps, but nobody bothered to put them in, so This can actually bump against the outside case, and if the plastic wears off, it can short to the outside case and short to ground and cause your GFI to trip. That kind of stuff, right? It's small things, but it's a lot of small things that can go wrong in power supplies. You want this stuff done correctly because it's dangerous. Mains voltage is dangerous. And on the Meanwell, even though it is not the absolute best quality power supply I've ever seen by a long shot, it is still a really good power supply. It is still carefully laid out. Like, you can also see these isolation slots everywhere, which make sure that high voltages, even when the board gets contaminated, because it's going to happen with an open frame power supply, dust is going to come in and ruin your day. Even when that happens, no problem. They have isolation slots that make sure that everything stays safe. Alright, in the next video in this series, I'm not sure if the series is going to be consecutive on my channel, I will actually be testing power supplies. This was just an intro to look at the difference between a no-name and a name brand open frame power supply. Hope you enjoyed it.